going to start with Unit 9. And you guys are going to ask any questions you have. Also, skip a step. If you didn't see your score, I sent it via Canvas and Insist. What questions do we have on the Unit 9 review?
Yeah.
I just said that.
I mean, like what?
I also just said that. Next class. Questions on the review. Evan, hold on. So you are looking at me instead of looking through the review for what you're going to be tested on next class.
How do we access
Go into math, go over to number, down to number 9. But you can only do this 2 numbers at a time. So if it's like a trinomial, you have to do the first 2, the last 2, and if those aren't the same, do the GCF of those 2. What numbers on the Unit 9 review do we want to see you go over? Also, I meant to mention this. Your 8-ball packets and JLabs are due, so if they're done, you can go ahead and turn it into this number 9.
Should do that? I'm sorry.
We do number 1 forward. Go. You're so
Does the 8-ball packet have to be like done?
It needs to be done 37. Make sure your names are on your 8-ball packets also. We're not doing iPads today.
Oh.
I'm going to check that right here so you can put it in camera.
Wait, so if we finish it, do we just put it
So I'm going to be just checking.
Could be 1 through 7.
I did all.
So I'm no longer checking 8-ball packets. As long as you've done through 7, I'm just going to grade them as is.
Yeah, but you didn't.
You didn't have to do
I have a 91.
You have to do through a 7.
I have a 95 class.
I have a 91.
Yes. That's sad.
So we're going to start with number 1 and then do number 9. With the factoring, remember for the factoring test there are 2 objectives, factoring and dividing polynomials. The factoring piece, you just know how you need to be able to distinguish the different types of factoring and how you do that. So for number 1, you have 2 terms. You can do that one of 2 ways, either by difference of squares or GCF. Which one could we use here? Are these perfect squares? We could use GCF. These are not perfect squares, so that one's already out. So you can either use your calculator using what I just said, go into math, go over the number, go to GCE, and type in those 2 numbers, 28 and 63, with a comma in between. Or you could list out on the side factors of 28, factors of 63, and see which one is the highest. 7 would be the GCF. What else do they have in common? B. And then I'm dividing 7b from both terms to see what's left. If I divide that from the first term, what would be left? 4a squared minus
9.
9. Now, a lot of the times when you factor out a GCF, there's nothing else, but you have to double check. Can you do anything else with this? Could you do GCF or difference of squares with that inside piece?
No.
Not GCF. Are these perfect squares?
Yes.
Yes, so you could use difference of squares. So keep bringing down your GCF. Split this into two factors. Focus. And you're looking for what times what would give you 4?
2.
What times what would give you a squared? 8. And what times what would give you 9?
3.
And then put a plus and put a minus. It doesn't matter which one is plus, which one is minus. So then your final answer would be that. We can't do anything else with those. So there we practice GCF and difference of squares. Questions on that before we do 9? For number 9, this is 4 terms. There's only one way to factor with 4 terms, and that's by grouping, where you split the middle and look for what could you divide out of these first two? X. What would be left?
X2.
X squared plus 3. What could I divide out of the last two?
-5.
-5.
Whatever.
Yeah,
Yeah.
3x.
It's 3x.
Oh, it's
It's
3x
3x
squared. Okay, so this would be x squared. This would just be x. And then what would be left after that?
X minus.
It would be plus because we're dividing by a negative. Remember that with grouping, you want these insides to be the same. Then the outside terms are going to go together, x squared minus 5. And then the inside terms, you just bring down one of those. If this was some perfect square, 4, 9, 16 something, you would factor this, split it apart again. But that is not the case here. That is your final answer. Questions there? Other factoring questions? Okay. With number 6, I would say go for a GCF first, even though these are both perfect squares. If you did the difference of squares first, you're going to end up with the GCF in both. So get rid of the GCF first. I could divide these both by 4. What would be left? X squared minus y squared. And now we could use difference of squares just in that inside. If we split that, what would those two factors be? What times what would give us 16? X squared.
4x.
4x. And then what times what would give us y squared? Minus y and plus y. Other factoring questions?
Number 5.
5. After this one, I would say focus more on your trinomials. So these are not perfect squares. So GCF, what do they have in common?
W.
And
3.
3. So 3W. If we divide that out, what's left? the squares even though it's to the fourth. Anything that's even, you can still split. You would just take that exponent, divide it by 2. You have 4w squared minus 1 and 4w squared plus 1. But 4w squared minus 1 is another set of perfect squares, so we have to do it again. What would this break down to? 2w and then plus 1 and minus 1. So if you see something to the fifth like that, you'll have a bunch of factors. Questions on that? Catherine?
Why did we only split the one with the
Because difference of squares only works if you're subtracting.
What's that part? The third.
Sorry, say that again.
What's the third, like, one in parentheses?
What part?
On the bottom, you have 3 instead of 2.
There's, yes, because this got brought into 2. Okay. What other factoring questions? I will say your Desmos hacks, to some extent, kind of still work in the calculator for your trinomials. You could put in the trinomial, change your variables to x, and then put in your final answers and see if they cross at the x-axis. And that would tell you those are the true factors. If they don't, then they wouldn't. So I'm going to say this one's another grouping one, where we split the middle. I would say find a trinomial, a 3-term one. So in this case, look for a GCF first, always. What would that be? 3. And what variable? XY. So 3xy, we're going to divide that from each term. What's left? 8xy minus 2y plus. Now, if this were a trinomial with only one variable and the first term was squared, then we could keep going. This one we cannot. This was just a GCF problem. That is your final answer. I can't do anything else with this. It's not squared, so I can't use my trinomial rules. Other questions? You can also look on the back. Is another difference of squares. So it would be 10 minus 3y, 10 plus 3y. Let's say if you have trinomial questions, we can do that. We've done a bunch of different systems.
24.
Which one?
24.
What would the GCF be here? Doesn't have one.
Six.
6 going to 4.
4.
And does it have any variables in common? Both
I mean,
x
no
and
y.
y? Just one. So if I divide 4y from each of these, what's left? X squared minus 6x plus 9. So now we have a trinomial where the first term is squared. That is your a equals 1 trinomial, where you're looking for two numbers that multiply to be 9, but add to be negative 6. So I would keep bringing down that GCF, and I would write this in two factors, whatever the variable is, put that first, and then put those two numbers. And if you were to distribute it back out, you should get that trinomial. Questions there? Any other factoring questions before I have you write down? Somewhere where you have space, write these down. In the past, we have done these. So write these down somewhere. I want to make sure you're writing these down somewhere. If there are any of those we want to do, we'll do that after I have you write down two more, but it's not on this page. So. And somewhere else where you have space, like this. These won't take up much space because they're difference of squares. These two are difference of squares questions, so like at the top on the side. And then are there any of those 6 problems we want to see you go over before we jump to the next piece of Unit 9? problem like this, it's two terms, they don't have anything in common, it's not GCF, but I can use difference of squares here. And you're just thinking the same thoughts. What times what will give you 4? What times what will give you 25? What times what will give you x squared? So all of that combined, what would that first term be? 1, 2 fifths x. And then what times what will give you 9? What times what will give you 100? 3 tenths. Plus 3 tenths minus 3 tenths. Any of the other 4. Yes. So we'll just do that one for time purposes and then move on. So if you see something like this, where the last term is a fraction, you want to get rid of all the fractions by multiplying the whole thing by whatever the denominator is. And then you're going to change everything by multiplying it by 36. So 36w squared negative 84w. And then the 36 is where this cancels, so plus 49. And then you can see, does this have a GCF? So I'm going to use the calculator function to try each one. I'm going to do the first 2 and then the last 2 and then a combination of those 2. Math, number, GCD, 36, 84. Then I'm going to do it again, but change it to 84 and 49. It doesn't matter if they're positive or negative. I see that I got 2 different numbers, so I'm going to do it one more time using those 2 numbers. But 12 and 7 don't have anything in common. So there isn't a GCF between all 3. Which means we then have to multiply 36 and 49. And find 2 numbers that would multiply to get this, but add or subtract to be negative 84. I know that 36 times 49 works. I'm sorry, 36 times 49 will give me that number, but if I, they would both need to be negative. If I were to add them or subtract them together, I get negative 85. So it's close. So it has to be somewhere in between 36 and 49. So we'll just start dividing. 1764 by 37. 1764 by 38. By 39. By 40. 41. And then none of those work because they're all decimal, but 42 and 42 work. So if I make them both negative, this will be 36w squared. I would split my middle number to the 2 numbers I just found. So I can make this grouping, 4 terms. Split the middle of that. And then find the GCF of the first 2, which would be 1. W. And then if I divide these both by 6, what's left? 6W minus 7. And then what could I divide out of these last 2? what would be left? 6w minus, so then we have 6w minus 7 twice, or 6w minus 7 squared. Either or. Look at the dividing polynomials by a monomial page. Find any questions you want to see, you go over, have questions about.
Number 7.
With each of these, you can do this one of two ways, either by separating it or by factoring out the GCF of the numerator. So I'll do this one by separating, the next one I'll do by factoring, and then we'll choose. So separating it, I'm just going to rewrite it with each term over the denominator. And then divide each one using your exponent rules. So this first one, 12 divided by 3 would give me 4. And then I'm subtracting my exponents, so x. 15 divided by 3 is 5. And this one, we're going to have a variable in the denominator, because this would be x to the negative 1. So that would become 4x plus 5 over x. So anytime the denominator is bigger, you're going to have a fraction. Other questions? Look on the back as well. On the back. This one we'll do by factoring. So find the GCF of these two terms of the numerator. What do they have in common? 2, 1c, 1d. If I were to divide that, what's left from these two? So just from these two. 9c minus 2. Now, when the factored part and the denominator are exactly the same, they just cancel. Whatever's left is your answer. But if it's anything slightly different, like this one's negative, when I divide that, there will still be a negative out front. and I can't have anything left out front, I would have to multiply that back in. So you'd end up with negative 9c plus 2d. Other monomial questions before we jump to binomial? Look at the last section, the binomial questions, dividing polynomials by a binomial. Find any questions you want to see, do go over there. So with each of these, you have to factor the numerator, however it needs to be factored. And then at the end, you'll get like factors and you'll cancel. So this is a trinomial where a equals 1. So we're looking for two numbers that multiply to be 21, that add or subtract to be negative 10. What two numbers will work? 3 and 7, if they're both negative. So that would be x minus 7 and x minus 3. And you would put those both over your denominator. You have like factors, cancel those out and see what's left. This one also slightly works in your calculator. If you were to put that original in, it would give you a line. It's kind of hard to count the slope and y-intercept on the calculator, but you could look at the table and count them there, and you would get slope of 1 and a y-intercept of negative 3. Other binomial questions? Take a couple minutes. If you need to go to the bathroom, go get water, stand up, stretch, do that before we jump into unit 10.